Hello, everyone. This is Larry Sampson on our Lunch with Larry series. Thanks for coming back to our webinar series here. This is our last of the operational excellence series that we're doing. We started with a discussion with Cisco Vicente and the FDA, went to design transfer to talk about engineering bombs and how they transfer to manufactured bombs in the bill of process. Last week was operational simulation, so we really talked about plant sim and how to simulate your plant activities. And today we're going to talk about manufacturing execution. So very excited about this discussion, give you a sense of it. I'll just move to my next slide. And because this is our last of the series, the next series that we're going to do, we're going to take the first couple weeks of July off just for the 4th of July. And after that, we're going to do another session on design excellence. And what we're going to do is talk around mechanical design. We're going to have a bunch of topics related to simulation. And those different activities really are going to be centered again around the ventilator model. And so this is our Scan Me, this is our QR code for that session. Very interesting topics. I think you'll get a lot out of it. So feel free to go ahead. I'll put up the slide at the end too if you want to register. This is all my contact information, as you know already, but phone number, email addresses, LinkedIn account, whatever you need to get a hold of me. So if you have any interest or wanted to have further discussion, be happy to do that in the future. So that's kind of where we're at, and look forward to this new discussion. So today we're going to talk to my colleague. We've been working together here for 4 or 5 years, Raj Raghupathy. He's a director of our digital manufacturing, and really his focus is on Op Center and manufacturing execution systems. So Raj, maybe you could give a little summary of your background, if you don't mind.
Yeah, no, thank you, Larry. Good afternoon, good morning, good evening, everyone. So, yes, Larry said, my name is Raj. I've been with Siemens for, more than 15 years. And I've been focused on medical device diagnostics in, smart manufacturing, digital manufacturing, Industry 4.0 initiatives. And, good to talk to you today.
Yeah, super. So maybe we could just start with, I hear, one of the topics that comes up quite a bit is Industry 4.0 and digital manufacturing. Maybe you could kind of give us a summary because we get a lot of questions around that. It'd be nice to have a better sense of what people mean when they talk about digital manufacturing and Industry 4.0.
Yep, no worries. Let's get started on that, part. Thanks, Larry. So, when we think about smart manufacturing, digital manufacturing, as part of Industry 4.0, it really, means, different, ways to look at the same problem. So let's start before, we talk about that. Let's quickly see, what the journey has been, right? So since 1980s, 70s, 80s till 2000s, from a business perspective for manufacturing is, to add computing power, right? I mean, we used to have, different types of technologies, but the whole idea is how can I help enable manufacturing and business processes by adding computing power. After 2000, the last 10, 12 years has been more about, let me connect, the systems that we have. Right. I mean, it's either connecting the ERP system to my, PLM system, connecting the PLM system to an execution system, so on and so forth. It's all about connectedness. And now we are in an era where we are getting into this digitalization, right? I mean, we'll talk a little bit more about how it gets into, digital manufacturing, smart manufacturing, Industry 4.0, different countries call it differently based upon the way how it's organized. But the whole idea of this digitalization, has changed, made some changes, permanently. Since 2000, if you really look at the top, more than half of the Fortune 500 countries don't exist today. And one of the main reasons is that they fail to adapt with this digitalization part. So what is it, right? I mean, so what is this digitalization? How is it related to manufacturing? So think about smart manufacturing to be, it's really integration of intelligence, right? So when we talk about integrating the intelligence, so from where, right? The intelligence is from the machines. The machines have some intelligence. The parts have some intelligence. The materials, the products that you make, the buildings that you have to make, the supply chain, all these, parts of your, supply chain, they have intelligence. The idea is that smart manufacturing really brings together, integrates this intelligence in an open, connected way so that you can get derived benefits that you could not, get it before. Simply put, smart manufacturing and digital manufacturing means really, smart machines, which is really, machines that can talk to each other or communicate with other systems. Smart products, these are products, like, you may be wearing a diabetes sensor, a continuous glucose monitoring diabetes, device that actually communicates to you. It may be about having a defibrillator, that communicates back to you. So this is the smart products, products that can communicate among other products or, communicate to the designers or to the consumers. And smart logistics, this is really, having intelligence in your logistics and of the value chain. Now, all of this, even when you harness this intelligence in using open, integrated, and communicated systems, that's really, is what smart manufacturing, is all about. So when you, really think about, let's take a, very simple example, right? So here, what you are seeing is with our technology, from Siemens, right? So you are looking at some plant performance related data. So you are looking at overall equipment, efficiency and effectiveness, which this is a metric that is used to track your equipment effectiveness. And it's really a compound metric. It's made up of three individual metrics, right? It has availability, performance, and quality. It gives you a very bird's eye view of this data. This is easy, right? I mean, this is what you would expect if you have any type of digital manufacturing. You have to get the data. You should be able to visualize the data. And in the middle pane here, you are looking at the trend of the different, OEE in a given site. So this is one equipment or one production line, and here you are looking at the trend. And it also tells me that there are 11 incidents, something happened, right? Machines come into the picture. Now, one of the reflow ovens, looks like it has some issue, right? So I'm going to go click on this, reflow oven, and I can go look at, the, actual data from, the reflow oven, right? I can look at, the temperature, I can look at, some parametric data, right? I mean, what is going on in this equipment, because it says that it is down, but why is it down? So I can, quickly have a real-time look in what is happening. So smart manufacturing, again, is the idea here is that, the machine is, you are able to communicate with the machine, in this case, the oven. And, you also want to go and understand, the model, right? I mean, what is happening, how was this oven supposed to be working? How was it designed? So you as a engineer, not only you are looking at the overall OEE or effectiveness of the equipment, but you are very quickly understanding that something went wrong and you are trying to get into the design part of it and saying, what happened? This is my bill of materials as designed, right? So I can go click on, I can browse through and understand, what problems we are, having. Maybe now as an engineer, I decide that, something needs to be done. And that's what smart manufacturing is all about, or digital manufacturing is all about. Now I have the data, I looked at the data, I look at the design, all of this digitally, but I want to send a technician to go work on it or to go investigate what the issue is. So here I'm having my overall dashboard of all my service technicians, my maintenance equipment, in my crew. and I can see if they are available, if they are working, in this case, they're on job, they're available, so on and so forth. Now I have this reflow oven. I can go and schedule this, saying that please go and, investigate the problem, right? So I can go ahead and complete it. The service technician gets a note and they, get to work, with the same data, right? So that's really, one example of, smart manufacturing or, digital manufacturing. Now, we, Larry, as you know, we Siemens have been leading, the industry by providing best-in-class technologies to enable companies to get on the smart manufacturing journey. For us, it is really about enabling our customers to have a model-based, data-centric product design. This is really the digital design, digital twin of your product. We last week, and we talked about the digital design, model-based design of your production system. And the idea of having this digital twins is that you can do the what if analysis, you can optimize the product and the production plan, and then send it into the execution. This is what we were kind of talking about a little bit here. And then you are also getting data from your equipment, from your product, so on and so forth, and you are seamlessly integrating the data across the different domains for you to get to some business problems. So Larry, that's kind of how we see digital manufacturing, smart manufacturing, and Industry 4.0, in the context of manufacturing.
Sure, fantastic. So maybe what we could do now is move more directly into manufacturing execution. So maybe you could talk about, maybe describe the purpose of manufacturing execution and how it serves to control the manufacturing process. Give us an idea about that.
No, that's a great question, right? When you really think about, okay, what is the role of manufacturing execution system, manufacturing operations management system, different terminologies. What is the role to enable smart manufacturing? Is really right here. I mean, this diagram probably explains it really well. MES systems or MOM systems really is the backbone for you to make digital manufacturing and smart manufacturing a reality. This is where you are tying the data from the upstream design, whether it is the product design or the production process, production system design. You do all the optimizations, and then you have to send it to an execution system, which really orchestrates your manufacturing and quality processes, including your acceptance activities. And it also provides you data about the performance of the manufacturing process. You can get the performance of the product from the field, and you can bring them all together, to improve your product and process design. So that's the whole idea, right? Now, if you take one step closer, what does this manufacturing operation system, manufacturing operation management systems do? I mean, this is again a good representation. We again, Siemens, we have our industry leading best in class solution. We have 15 out of the top 20 med device and diagnostics customers use our solution, to enable digital manufacturing, smart manufacturing. And this kind of gives you a functional view of what all we can handle, right? So typically there will be some scheduling, there will be some manufacturing change, there will be some quality processes, your acceptance, activities, your inspection planning, execution, your quality management around non-conformances, containment, disposition, and the backbone is really your, router process, and tracking the work order with a 360-degree genealogy, with inspection. And typically this system, integrates with your smart machines that we just saw, or even, other type of equipment, using an automation connectivity. This is where the open systems of the smart manufacturing comes in. We can connect with the, shop floor layer to receive data and to send data. We also connect with the upstream. Obviously, we have our out-of-box, we connect with our upstream design, process design, optimization system with Teamcenter, right? So that's kind of what we do. And when you think about medical device and diagnostics, I mean, you can think about the ventilators, currently the topic, the hot topic for the last few months. That's basically a serialized, product. The way how you build a ventilator and the way how you will build the test kit reagents for testing is very, very different. So there is a wide variety of manufacturing processes, and we handle the entire variety, right? So we handle the ventilator type of production, which is serialized in assembly, lot-based manufacturing processes. We do have orthopedic customers of ours, who do more machining, grinding, polishing, super finishing type of operations. We have PPEs, contact lenses, single-use dialyzers, reagents, all that in the continuous batch manufacturing. And we also have customers who make personalized medicine, personalized offering, therapeutics, where you are really building, there is a single DMR for every unit that you build and the DHR for every unit that you build.
Okay, well, fantastic. Yes, and one of the things that I think people really struggle with regard to manufacturing execution is how, it's typically a manual creation of their device history record. And so maybe what we could do is describe for them how they would develop this electronic device history record. Maybe you can explain what that is and help them understand how it could help their, their processes.
Oh, that's awesome. That's a great question, Larry, right? I mean, when you really think about our medical device and diagnostics, customers and clients, they really make two different things, right? They make the product, if you are, whether it's a ventilator, it's a defibrillator, PPE, whatever it is, you make the product, and then you make the paper, which is really the, records, the compliance record of how you built the product, assembled it, manufactured it, inspected it, shipped it. And that paperwork, you have to maintain for the lifetime of the product, and you have to make it available from audit purposes, right? So that's really called the device to record or the batch record. And both needs to be perfect because you got to demonstrate the quality of the product, the build quality of the product by showcasing the device to record or the batch record. We all know that, most med device companies spend twice the time in testing the paper than the time that they spend in testing the product. And that's actually a big problem, right? Because paper has a lot of issues, transcription errors, so on and so forth. There is also a business side of it, right? There is the business side of it is that, there is so much non-value added activities that happen because of this paper-based device to record process. What you are seeing here is an example from one of our, medical device and diagnostics customers. Think about a class 3 medical device product, roughly about 100 people in a clean room. And this is the amount of time that they had to spend before implementing, an EDHR type solution. Tremendous amount of time, cost, and it also has quality exposure, right? Think about 14 million data entries and having to maintain the accuracy on it. It's almost an impossible task if you were to do it manually. We have a different way to do it. The whole idea is that's where, Larry, your question of self-auditing electronic device to record comes in. So if you take the manufacturing, which is really simplified representation here, you are adding value to the received materials to make it a final product. And the whole idea with our technology is that the manufacturer can enable, the enforcements, right? I mean, you can make sure that the product that you are building is built the way how it was supposed to be built. So your DMR will have some requirements on materials, equipment, operator skill set, so on and so forth. We make sure that, those are all enforced at the time of the production process. We also manage the entire route, including the rework, so that there is no missed operations, missed label, operator missed something, or none of that ever happens. So usually, the work order does not go to the next step unless all the activities that is required to be completed is completed and it is accurate. So the whole idea is that when you go to the final product release, that manual device history record, that paper stack that you saw, you don't have to review it because it doesn't exist. Instead, you are having an electronic version of enforced and compliant and accurate data. So our customers, what they do is that they release the product without having to review the device to record, and they do review it only when there are exceptions, right? So that's the whole idea of eliminating the non-value add, and you are building quality into your overall processes. Now, paper doesn't talk back to you. The application does, because you're capturing model-based data, all of this information is available. You can use it to drive some metrics and KPIs, like what you saw when we started the discussion with, KPIs, like overall equipment effectiveness. All the data comes automatically from our application. You can also manage your acceptance activities, and the outcome of the acceptance activities could be a non-conforming condition. You can document it. You can manage the entire disposition MRB around it. Now, we also provide the next level, going back to the digital manufacturing industry 4.0. We are connecting now this non-conforming data with make, we are part of this Make Kappa Cool initiative, right? So you can send this non-conforming data into, a Kappa system, and we can tie the Kappa, into an engineering change system. Obviously we provide these capabilities as part of our comprehensive platform. That when you make a Kappa, you are not saying that you are making a change to your product or processes, but you are using the digital models to go make the change. You can test them, you can verify the effectiveness of the Kappa, so on and so forth. So it's a complete end-to-end process. We also have capabilities that helps you around, maintaining the, products that could be leased, like wearable defibrillators, dialyzers, so on and so forth. If you are a device manufacturer, then you have to maintain an as-maintained EDHR in addition as well.
Sure. To me, this is all about lean manufacturing, right? We're fixing the problem when the problem exists and not waiting till the end to review some paperwork to find out we had some issue at the very beginning, right?
Yep, no, absolutely. That's another way of saying it, Larry.
Yeah. So maybe what we can, there's this idea of handling or containing materials. How do we contain materials in the system? Maybe you can describe how that's done and how, sort of the value associated with the work that's required to do that.
Yeah, no, that's a great, question, right? I mean, let me, talk about this containment part, from the, application perspective, right? So the whole idea is that, say that you are having a problem, right? I mean, either a complaint or you have a non-conformance or, a Kappa, you are investigating and you have a problem. Now, you want to understand the impact of the problem. You want to understand the containment, right? I mean, so that you can figure out, what do you need to do in order to, bracket the material. Now, without having an electronic system, this process can take hours. And sometimes, you cannot narrow it down. So you would end up recalling or bracketing materials for a big time period. The whole idea in this case is that, you can very easily go ahead and say, search, the manufacturing activities based upon any parameters. So this is like your, any search that you may do, right? I mean, you can go and say, I want to know everything that happened, from January 25th till today, right? I mean, I can go and, search the application and, I'm getting the system returns. These are all the products that were, made, units, lots, batches, however you track them. This is all the information that is available. Now, I think that it's related probably to an operator issue, right? So I can go ahead and say that, I want to know everything that Andy had worked on. So very quickly, you can now narrow down further, right? So now you have a much smaller group based upon the time and the operator. So you get the idea. You can keep narrowing down the information. But more importantly, you can act on the material if the material is still under your control. So right here, I can go ahead and say, you know what? I want to place this material on hold, right? So you are assuming that this material is still being under production. You can go and identify, one or even, multiple materials and say, you know what, place them on a hold so that nobody is using it until someone clears it up. This is one easy way. Now, you as a manufacturer, you can think about the whole idea of UDI, right? The idea here is that what happens if the product has been shipped already. The ship data is available in another system. So we enable our customers. In this example, you are searching the UDI information, and it tells you the different locations that the product went through. This is where it was manufactured, distribution center, and this is where it's being used. You get a bird's eye view of the label that was produced, how you shipped it. You can go and get data from your ERP system. This is your location data. You're receiving your manufacturing, your distribution, your warehouse, data from that. You can get your design data. You can also get your, execution data, right? So the whole idea is that, again, think about digital manufacturing, smart manufacturing. It can go, this is the smart logistics part. You can go and search the material across your supply chain and identify and act on them, not merely say that sending emails that, you have to place the material on hold.
That example, I've spent 2 weeks doing what you just showed in 3 minutes. Makes me jealous of my earlier career. So just maybe for the last topic here, talk about closed loop manufacturing a little bit. What is it?
Yeah.
How do we enable it?
Yeah, no, that's a great topic. It's a larger topic, Larry, as you can imagine. It ties, the whole idea of closed loop manufacturing is it is with Industry 4.0 digital manufacturing and smart manufacturing. This is about having digital models where you can design and optimize the product, send it to the execution, and send data back from the execution to the design system. And so that when you act on, a problem, for a root cause, you are evaluating your action digitally, without having to go through painful iterations. You can understand the effectiveness of your kappa. Again, make kappa cool, project, right? So you can check the effectiveness of the activity, and you can complete it. What you are seeing here is some of the idea of the analytics that helps you with that. The whole idea is, again, think about all this data having made available to you. Now, what you can do is not only look at the trends, but you can do some machine learning based algorithms that can identify what combination of issues are really causing you the problem. These things without machine learning would be impossible for you to do it, but we enable with our technologies to get to solve problems like this. It's a broader topic, Larry. I'm sure we will have other discussions to talk on closed loop manufacturing overall, how it ties back into your design processes and getting data from the smart products, smart machines, and smart logistics, and using it to make effective and efficient decisions.
Sure. Well, fantastic. Thanks, Raj, today for the run through. I'm going to go ahead and just pop back to our Design Excellence Next series. So that is going to finish up our session for today. But really love you to register for the next series. We're going to talk about mechanical design, simulation, and electrical simulation, all in the context of our ventilator model. So all this data that we've been working on as this cross-platform demonstrator, all that's going to start coming together in mechanical design and simulation for products. So we'd love for you to engage in our next series as well. So go ahead and click on the link or do the QR code and sign up for the next session. So appreciate your time today, and thanks so much for coming. Thanks again, Raj. Appreciate your time.
No worries. Thanks, Larry. Thanks, guys.